In this topic, we're going to talk about two examples of bacteria which showing the antibiotic resistant and which is very important in the global. So the first one is MRSA, while the other one is multi-antibiotic resistant superbug. So the first one, MRSA, are called methicillin-resistant Staphylococcus aureus. First of all, bear in mind that I think you already learned about Staphylococcus aureus. Staphylococcus aureus is the bacteria that can commonly found through contact, skin, or surface. And one thing you must remember, Staphylococcus aureus, in fact, it can be easily destroyed by normal hand washing. So, in fact, MRSA, it can be easily be prevented through hand washing method. So for this Staphylococcus aureus, in a normal scenario, normal condition, it can be destroyed by antibiotic methicillin or oxacillin or penicillin. Remember all this. The methicillin, oxacillin and penicillin, basically they are same group of antibiotic. So the normal Staphylococcus aureus can be destroyed by this type of antibiotic. So those bacteria, those Staphylococcus aureus that can be destroyed by this antibiotic, we call them methicillin sensitive Staphylococcus aureus or MSSA. Here we're going to discuss is the one that resistant, which is methicillin resistant Staphylococcus aureus, also known as MRSA. So what is the definition? What is the meaning? So MRSA or methicillin resistant in the Staphylococcus aureus is defined as an oxacillin minimum inhibitory concentration of greater than or equal to 4 microgram per ml, which means if the Staphylococcus aureus require a minimum of 4 microgram per ml or greater than that of oxacillin to kill them, that means this Staphylococcus aureus is resistant. If you require below 4 microgram per ml, which means they are sensitive to this methicillin antibiotic. So why there's a different term of methicillin and oxacillin? In fact, when they first found the resistant level is they tested on methicillin. So when they found that this bacteria is resistant to methicillin, and then later on, and then they produce a modified version of methicillin called oxacillin. So that's why today when we give the definition, we say it is the oxacillin minimum inhibitory concentration. However, the original when they first found is resistant on methicillin. That's why today we still use the term of methicillin resistant instead of oxacillin. So how this bacteria MRSA they can acquire the resistance, we will talk about this later on. However, this MRSA it can be divided into two types, which is hospital associated or community associated. Hospital associated, which means the patient get this MRSA when they staying in hospital, while the community associated is the one that found outside the hospital. So now, how is important this MRSA? In fact, this MRSA today is very commonly found in hospital and even in your school, your classroom, and at your home. So then you may be curious, this bacteria is so dangerous, but why it did not cause death? Because this bacteria in healthy person rarely cause any severe illness, but this bacteria MRSA will cause severe illness in those immunocompromised patients like elderly people. So first of all, let's look at the cause why the Staphylococcus aureus can develop resistance to methicillin. In fact, because they produce this mutated form of penicillin binding protein, or in a previous lecture we call it as transpeptidase enzyme. This bacteria produce a altered form of transpeptidase enzyme. How come they can have this mutated form of transpeptidase enzyme, or we say mutated form of this penicillin binding protein? Because they having a gene called MAC-A gene. So in which scenario you are in risk of contacting with this MRSA? If you have prolonged hospitalization, which means when you go for you're hospitalized for very long, then higher risk for you to contact with MRSA. Or when you are going for ICU, or you have this invasive procedure, HIV infection, open womb, hemodialysis, and long-term endurance urinary catheter, or you are a healthcare worker, so higher risk for you to contact with MRSA. So pathophysiology, in fact, the bacteria, the bacteria can produce this mutated form of penicillin binding protein is because presence of this MAC-A gene. Because of this MAC-A gene, they can encode for this mutated form of transpeptidase enzyme, or we also call it as PBP2A. So this bacteria, by having this mutated form of transpeptidase enzyme, or we call it as PBP2A, it makes the antibiotic penicillin or methicillin or azoxystrobin unable to bind to them. So by this antibiotic is unable to inhibit the cell wall synthesis. This MRSA can continue to grow as they are resistant to this antibiotic. So this MRSA can cause the diseases like skin and soft tissue insect infection, bone and joint infection, pneumonia, bacteremia, and this endocarditis. So in terms of laboratory diagnosis, how can we diagnose this MRSA? So in fact, the current gold standard to diagnose MRSA is using PCR. So currently, in fact, in the case of this infectious control in the hospital, frequently when they want to transfer patient from one hospital to another hospital, they always to screen first whether the patient is having MRSA or not. So normally they swab this MRSA from the skin area, the joint area, to see whether this patient is having this MRSA or not before they transfer to another hospital. While the other one is in the ICU. In the ICU, frequently they swab whether this the bed or the counter area having this MRSA, because this MRSA is not so dangerous to healthy people, but it's very dangerous to this immunocompromised patient. And in fact, is commonly found in our community. So to treat this MRSA, the one that most commonly used is vancomycin. How to prevent? So as I said, this Staphylococcus aureus can be easily destroyed by hand washing. So it is very important to apply this strict hand washing. So for a healthcare worker, doctor and nurses, it is very important to always wash your hand before when you're touching different patients. So it's important to use gown and glove and the glove and mask to prevent contact with the patient with MRSA, and keeping patient in isolated room if the patient who have MRSA infection, and also actively surveillance to screen for MRSA. So that's why it is important in the hospital for them to have this infectious control, to always screen whether the counter, the bed, the wall having this MRSA or not. The next case of this global emergence of antibiotic-resistant bacteria we're going to discuss is this multi-drug resistant gram-negative superbug. So before 1960, gram-negative bacteria is rarely to cause severe illness, and especially in this antimicrobial resistance. However, since 2000, then it's frequently reported that gram-negative bacteria cause antibiotic resistance. The one that commonly is Acinetobacter baumannii, while the other one is Klebsiella pneumonia. So all of them are resistant to carbapenem. What is carbapenem? Carbapenem is a type of beta-lactam antibiotic. It is always used as a last resort when the patient resistant to almost all antibiotic. So when the patient almost resistant to all antibiotic, then doctor will consider to use carbapenem as last solution. But nowadays, some gram-negative bacteria start to show resistance to this last solution antibiotic, which is carbapenem. Which means in this scenario, when the patient is resistant to carbapenem, in fact, we have no more any antibiotic left to treat them. So the statistics show that the prevalence of this gram-negative superbug in Malaysia and also in United States. In Malaysia, the sample taken is from Hospital USM in Kelantan. So you can see that the increase in the number of this antibiotic resistant in United States and also in Malaysia. So for this carbapenem resistant superbug, actually they have further divided into several different groups. So that's why sometimes I heard about this new Delhi beta-lactamase resistant bacteria. So in fact, this bacteria is resistant to all antibiotic, even carbapenem. However, some of the strain they still so sensitive to polymyxin. So sometimes polymyxin still one of the possibility to use to treat this superbug. So if you look at the study here, so in fact, until in the past decade, only 2 new antibiotics have been developed. However, they are only showing targeted for gram-positive bacteria only. There are examples like linezolid and also this daptomycin. So there is until now is lacking of new antibiotic for gram-negative bacteria. So you can see this study showing that the new antibiotic have been developed in the past decades. So at the moment, actually we are lacking of new antibiotic in this moment. So the current solution is we only can use the old polymyxin antibiotic to treat if the patient is resistant to this. The patient is having this multi-antibiotic resistant superbug. While two other types of this polymyxin sometimes can be used, the polymyxin B and polymyxin E. Sometimes we can also combine the antibiotic, combine different antibiotic to achieve greater effect.